button. Domain and range. We've already talked about this a little bit, guys. And what we said was that we have sets of inputs, right? And we talked about that last class. What were the input values? Were they X's or Y's? X's, yeah. So let's make a little note. Set of input values. So in other words, the X values and then the range, which is our set of outputs, are Y values. Absolutely. Okay. Like super important, guys. Going to be asking you guys about domain and range literally all year long, pretty much every unit. Okay. It's going to keep appearing. Okay. So, Jane, here's what I got. I have a function, same way we defined it last class, right? What do I have here? I want to state the range if the domain is 1, 3, 5. What does that mean? It means the only values that I'm allowed to use or input are 1, 3, and 5. So what am I going to do? Well, I'm going to plug in 1. I'm going to plug in 3. I'm going to plug in 5. And you can use a calculator to do it, or you can use your head, or you can use your store, or you can use your define, or you can use your table, whatever you want, okay? What do we get? Well, we get 2 times 1 plus 1. So we get a 3. And we get a 7. And we get an 11. So what are my output values? 3, 7, and 11. So when I ask you guys about the range, look at my, are you guys impressed by my little curly Q, squiggly, curly bracket thing? I can't draw these. I've been trying for 20 years. That just looks awful, doesn't it? Look at that thing. 3, 7, and 11. Can't draw them. That's what they look like. State the domain and range in a mapping below. 3. What else did I plug in? What else did I plug in? 1 and 5. And what were the output values that I got? 3, 7, and 11. So where did the 1 go? Oh, wrong one. 1 went to 3. 3 went to 'So there's a mapping, right? That's a way that I can give you guys or ask you guys to represent the solutions, right? Hey, what about this? Could I ask you guys to write the solutions down as ordered pairs, right? So in other words, I could have you do like this. Right? That's a way I can have you write down the solution, right? Lots of ways we could write down the solutions. No problems there? Good. Okay, here's the graph, right? Multiple representations, going to see it all year long. Molly, if I asked you to go up to the board, put your finger on that function and trace it with your finger, would it have a beginning? Would it have an ending? Based on the picture that I have right here, right now. Yeah, because what's there not at the end of this graph? Arrows. No arrows means it stops, right? Everybody agree with that? Okay. So when I ask you about minimum x's and maximum x's, minimum, maximum, x's. Guys, all I'm asking you for is the point furthest left, the point furthest right. What is the extreme left? What is the extreme right? Isn't that going to give me the domain? Yeah, so I'm going to get on my function. I'm going to go all the way to the left. And when I get to the furthest point left, I'm going to write down this point. So it's -3, -2. Which of those is the x value, the -3 or the -2? The -3. So the minimum x value is a -3. Furthest left, right? All right, then I'm going to trace this to the right. And the point furthest right is the one right here at 1, 2, 3, 4, 5, 6, 4. So the furthest right is a 6. Question. Okay, but now I'm asking about what? Minimum x value, right? Because what am I going to ask you in the next part? Minimum y value, and now I'm going to be interested in the points that are furthest up and down. So that brings you to the next question, okay? So now I want the minimum and maximum y value. So what am I going to do now? Now I'm going to trace my graph, and I'm going to stop when I get to a point that is lowest or highest. So what point is lowest? Well, this point right here is, correct? And what is that point? That's the point 3, -1, 2, 3, 4, -5. Now, which value of those do I want? A -5, because I asked you for the y value. So the furthest down. And then the furthest up would be, well, hang on a minute, it's right here, and we already have that point labeled, so what am I looking for? The y value, which is 4. All right, so I have furthest left, I have furthest right, I have furthest down, I have furthest up. That's going to give me my domain and my range. Fair enough? Now, typically, guys, we like to represent this with something that is a little bit, I don't know, a little bit more dignified than just saying furthest left, furthest right, furthest up, furthest down. So one way that we can do this is by putting things in set builder notation. Guys, set builder notation is nothing more than a really, really fancy inequality. Okay? It's nothing more than a fancy inequality. So, T, if I said furthest left is -3, furthest right is 6, give me an inequality that represents everything from here to here with an x in it, how would you do it? Yep. So how would I write that inequality? So when I say inequality, guys, I'm talking about less than, greater than, less than or equal to, greater than or equal to, things like that. So I want an inequality, Tim, that basically represents this. Ready? Here's -3 on a number line. Here's 6 on a number line. Here's the values in the middle. So go back to your algebra class for a minute. How do I write that inequality? Starts at -3. Do I include -3? Is -3 part of the answer? So I go less than or equal to. I put the x in the middle, and where does it end? With a less than or equal to. Now, the only difference between writing the inequality and writing the set builder is this. What variable is in that inequality? You put an x in front with a nice vertical line, and you put the curly Q's around the whole thing. How do we read that? Like, how do we read that thing? X is an element of the inequality. -3 is less than or equal to x is less than or equal to 6. That's how you would actually verbalize that. That is the set builder. Yep, this right here is called set builder notation. That is set builder notation. Okay, so if I asked you guys to do the next one in set builder notation, what would you have? You'd have an inequality that starts at -5. But now I'm going to use a y value, right? And where does it end? At 4. Now what variable is in the inequality? The y. So I do a y with the vertical line, and this, well, that was a pretty good little one, right? Look at that squiggly. And there is my what? There's my set builder. Now Trinity asked a good question. She said, "Because is that the set builder?" Okay, yes. Do you guys remember there's another way to write these things though? Sets of numbers. There's a different way to write it. What was it called? Well, it's right below. What's it called? Interval notation. Absolutely. So really quickly, let's write down what the interval notation is. Right? I know it doesn't say to do that. I'm just going to do it for you guys so you can see it, okay? What is the interval notation? Okay, here's the way I like to do it. T, you know how we just did this up here? That was kind of nice, right? It was kind of nice because it gave you a nice visual, didn't it? Okay, so here's how you do intervals. Intervals are the brackets and the parentheses, right? The way that I like to do them, and I like to put it on a number line. I like to start moving along that number line. I like to ask myself, what's the first thing that happens? Well, the first thing that happens is I start at -3, right? Am I allowed to be -3? I'm seeing lots of heads shaking. Yes. Why am I allowed to be -3? Because what did I do to the circle? I closed it. It's filled in, right? Well, with interval notation, do I use a bracket or a parenthesis to represent something that I'm allowed to be? Bracket. Good. So this starts at -3, and then it keeps going until I get to what? Until I get to 6, and then the event ends with a bracket because I'm allowed to be 6, right? That's your interval notation. A little cuter, right? A little more streamlined. What's wrong with it, though? There's no variable in it, so I don't really know what it refers to. That's one of the problems with interval notation. Okay? The next interval would simply be what? It starts at -4 and it ends, I'm sorry, -5 and it ends at 4, right? So that's the interval notation. There wasn't a lot to really review right there because the answers were pretty much the same. Blake, what if I asked you to do this? I want to see the interval for this. X is less than 2. So, Blake, you might say, well, you know what, Picardo, I like that visual. X is less than 2. So it's not filled in because what? Am I allowed to be 2? No. Less than is which way, left or right? Okay, ready? Here, I'm going to blow your mind. Ready? If I ask you to hop on this number line as far as you can to the left, that's part of the answer. Part of the answer, furthest to the left. You'd have a problem, right? You can't get furthest left because it keeps what? Just keeps going. So where does it actually start? Somebody said it over here. Somebody said infinity. Somebody said infinity. But here's the problem. There are 2 different types of infinities. There's a positive infinity and a negative infinity. So which one you want to use? Negative infinity, right? Because to the left are the negative values, right? So I'm going to start at negative infinity. Now, oops, that's actually 8. Now, quick question. Can you physically take your finger and touch negative infinity? Why not? Because it keeps on going. If you can't put your finger on it and touch it, we use a parenthesis. So let's suppose hypothetically you found a way to get to negative infinity and you started coming this way. What's the next event that occurs? 2. Am I allowed to physically be at 2 and touch 2? No, so what do I put on it? Parentheses. So there's your interval for that. All right. What if I went the other way? What if I said, give me x is greater than or equal to 4? Well, you would have a number line. You would have 4 on it. And what is your sketch going to look like? Well, you're going to have a circle at 4. Is it going to be closed or open? It's going to be closed. and I want x is greater than or equal to 4, so I'm shading to the right. Okay, yep, I'm going to positive infinity. But remember, one thing that's real important about this, when I get on my number line, I always get on my number line furthest to the left. So I start all the way over here, and I start coming in. The first thing that happens starts at 4. Am I allowed to be 4? And I keep going until I get to the end, but I don't ever get to the end because I'm going to infinity, but I can't ever get there, so I put a, there you go. Okay, so a quick, real dirty review of interval notation, right? Set builder is x is an element of, so it's one of these. Interval is one of those. Do me a favor, guys. Star this, because I know your first quiz and your first test or whatever will ask you to give me specific form of solution. Okay, so you need to know the difference between those two things and be able to produce them both. All right, we're doing great. Guys, here I have a picture of a parabola, right? And it says that it's this function, which of the following represents the domain and range? Well, here's my issue. I get on my function, yes? So to find the domain, I have to get on my function and I have to go furthest to the left and furthest to the right. So when I say domain, I'm talking about left and right. Talking about range, I'm talking about down versus up. So if I get on this function and I go furthest left, I got a problem because of the what at the end. So give me a general direction where this goes. This arrow is pointing this way. What does that indicate? I'm going to keep moving to the left and I'm going to keep moving up. Fair to say? So if I'm going to keep moving left, where is this going to eventually lead me to? Negative infinity. So for furthest left, negative infinity. All right, so I start moving along this to the right. And where am I going to eventually get? To positive infinity. All right, so there's my domain. Those are my x values. For my range, I'm going to get on my graph, and I'm going to follow my graph until I get the value that is furthest down. What point is furthest down? It's this one, right? That's the value 1, -4. So I'm going to start my graph at -4. Now, what do you notice I did, guys? I put a bracket. Why? Because I'm physically able to touch that value, right? So now I have to go furthest up, and I have some options. I can go to the left or I can go to the right, but it doesn't matter because either way I go up, 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 up to infinity with a parenthesis because I can't touch it. Very good. Come on, pen. All right, so there it is, guys. Which choice is that? That's choice 3. Cool? All right. All right, again, multiple representations, right? I gave you a graph. I gave you a function. Now I'm giving you a table. So here it says, the following function has outputs given by this table. Evaluate f of 1. Guys, do I really need to plug 1 in? Why not? I have a table that's right here. So f of 1 is -1. F of 6 is 6.5. Why does the calculator give an error at 4? Jameson. Okay, so here's the problem, right? Guys, if I take 4 and I plug it in right here, I get 2 times 4 plus 1, which is 9. But what's 4 minus 4? Am I allowed to divide by a 0? No. So when I evaluate f of 4, I get 2 times 4 plus 1 over 4 minus 4, which is 9 over 0. And this is not allowed, right? So this is what's called an undefined fraction, right? Which means that it does not exist. It doesn't happen. It doesn't work. Can't do it. Are there any values except for 4 that are not in the domain? Well, guys, as of today, as of right now, as of right this very second, as of this minute, the only thing that makes something not work is when I have 0 in the bottom of a fraction, right? The only thing I can plug in to get 0 in the bottom of this fraction is 4. So everything else must be in the domain. No. So write the domain. Ooh. How do I write everything except for 4? So I want all values except x equals 4. So I'm going to show you a couple of different ways that I can write this. Here's one way. What the heck is that? What's this mean? All real numbers. Make a little note of that. When you see this, it looks like a weird R, doesn't it? With like an extra line or something like that. This represents all real numbers. So my solution is all real numbers with the exception that R cannot be 4. Cool? That's one way to do it. Kira. I actually wrote down Kira. Kiara. Kiara. Yes. A semicolon. Yep, this is a semicolon. All real numbers, semicolon, except x can't be 4, right? So that's one way you could do it. Here's another way you could do it. I want to do it in set builder. So watch what I'm going to do. X is an element of all real numbers with the exception that x cannot equal 4. Looks kind of like what I just did, right? But that's how you would do it as a set builder. Blake, this is where I figure out if people are paying attention. Ready? Because now I want to do this. Here's 4. Blake, how do I do everything except for that? Well, I put an open circle here, right? Because I can't be that. But then I want everything but that. So what am I going to do? I'm going to shade both ways. So what does that mean? That means everything except for 4. So follow my rules here that we talked about a few minutes ago. Carly, help me out. I'm going to hop on this solution as far left as I can. Where does it begin? Negative infinity. So I start at negative infinity. And I'm going to start sliding along this until something happens. Cesar, where does something happen? At 4. Am I allowed to be 4? So what does this mean, guys? Doesn't this mean everything from here over here except 4? Sound good? Well, what about everything on the other side? Well, watch what I'm going to do. With the union, right? A union means I want all this and I want all that. So I want this interval and I want the next interval. Well, where does the next interval occur? Well, it goes to infinity, right? But where did it start? So now I start at 4 and I go to infinity. So what does that mean? That means everything with the exception of 4. By the way, hey guys, how would I do all real numbers as an interval without excluding anything? I want all real numbers. Wouldn't that be the way I would represent all real numbers? Negative infinity to infinity with parentheses on both ends, right? So to exclude something, I just simply what? Throw that exclusion in between with parentheses. Oh, good. This is the last thing of the day. The last thing of the day says, which of the following x's would not be in the domain? Well, if you paid attention to the homework last night, and you paid attention to the question that Jameson asked, then you know what's going on. Because what am I not allowed to have? I'm sorry? A negative value underneath the radical. Well, if I plug in 0, what's 0 plus 4? 4, that's good. If I plug in 5, what's 5 plus 4? That's good. If I plug in negative 3, what's negative 3 plus 4? Plus 4 at times. And if I plug in negative 8 plus 4, negative 8 plus 4 is the square root of negative 4, which is not in the domain, I should say. Not in the domain. And there you have it.
So because it equals a negative, it's not.
Yeah, because we can't take the square root of a negative number, right? So plugging in negative 4 gives, or plugging in negative 8 gives me the square root of a negative number, which we can't do for the reasons we talked about earlier. Happy? Any issues? You guys are a wonderful audience.